Hello everyone. I, Nilesh Kumar Sen, working as an assistant professor at a Computer Science Engineering AIML department of ABES Engineering College, Ghaziabad. In this tutorial series, we are going to cover the very first topic, that is Introduction to Memory Management. In this tutorial, we are going to discuss about definitions of memory management, what are its importance, what are the goals, and important topic from this particular tutorial is basic peer machine and resident monitor. So memory management is required for an operating system because there's a bulk of memory available for to perform a particular task. But whenever the process or a particular program or a process requires some memory space to execute or to perform some calculations, it requires some memory space. So it is the first task of operating system to provide memory area or memory space to that very process as and when required, and also deallocates that memory space once the space is freed. So the main concepts of memory management involves controlling and coordinating between computer memory resources, allocation and deallocations of memory space for processes, prevents issues like memory fragmentations and memory leaks, and ensuring that efficient utilizations of available memory resources, try to minimize conflicts as much as it can, and ensuring a smooth system operations. These are the main components or concepts behind memory management. Its importance required because of resource utilizations, stability, and responsiveness to perform various processes. It includes encountering stagnated performance, involved debugging, and even program crashes. It has to find out when that memory management is required. Goals of memory management. Here are some listed goals of memory management are there. Optimal resource utilizations, allocation, as I earlier told you that allocation and deallocations of memory for a particular process is done by the memory management, and it's purely up to the requirement of the processes. Prevention of memory fragmentations means it requires some techniques for such as compactions and relocations for preventing memory fragmentations. It also ensures about contiguous and usable memory. Preventing memory leaks, it is the main task of memory management from the operating system point of view to identify and rectify the memory leaks, preventing system instability and performance degradation. Ensuring system stability means it has to look forward for the possible crashes, freeze in the memory, and performance related issues for the proper memory management. It also maintains stability and responsiveness even under heavy workloads when number of processes or threads are moving to and fro. Supporting virtual memory, it is the main concepts of memory management. It enables implementations of virtual memory for the user and for the OS also. Allows program to use more memory than physically available. Means if suppose a particular program requires 50 MB of memory and in our system physically 50 MB is not available, then some part of our existing secondary memory would work as a primary memory. So the management between the secondary and the primary one is all about virtual memory concepts that we'll cover in the later part. But for now, temporarily transfer data from a storage devices like HDD, SSDs to the main memory, and accommodations of large programs and multitasking without requiring excessive memory. Basic beer machine. In the era of 1950s to 1970s, when there were no operating system exist, and we are we have to work on we have to work some calculations, or we have to work provide some processes to the operating systems. So at that very time, we are going to convey those processes manually. Basic beer machine is nothing but a complete system without operating system. When there were no operating system exists, so execution of an instruction is done by directly on hardware without using any interfering hardware. It also requires a particular person who has sufficient knowledge about computer field are the only one who are capable to operate a computer. Resident monitor. Now, this resident monitor can be considered as an operating system for that very time when we are working on the basic VM machine. Actually, in that resident monitor, there's a code that runs on a VM machines. That resident monitors works as an OS that controls the instructions and performs all necessary functions as operating system do in the present time. It also works as a job sequencer because it also sequences the job and sends them to the processor. After scheduling the job, resident monitors loads the programs one by one into the main memory according to their sequences. And most important factor about the resident monitor is that when the program execution occurred, there is no gap between the program execution and the processing that is going to be faster. Resident monitor is having four different parts. Now we are going to discuss about drawbacks of basic VM machines. So drawbacks of basic VM machine is nothing but what VM machine accepts instructions in only machine language. It is obvious that number of persons are not capable enough to learn or to work upon machine languages codes. So a particular person or a skilled computer engineer is required to operate such machines. Once the development of operating system happens, basic VM machine is just referred to as inefficient. As I discussed earlier, resident monitor is having four different parts, that is CLI, control language interpreter, job sequencing, device drivers, and interrupt processing. It is separated with the user program area. One can consider resident monitor as it divides the whole main memory into two parts. One part is for the user program area and other part is for the resident monitor, means a particular code that works like as an operating system. So very first part of resident monitor is control language interpreter. That is the part which is used to read and carry out the instructions from one level to the next level. As we discussed that we are passing the machine language code, so that that machine language code is passed one after other for the different steps or different parts of resident monitor one by one. Second is loader. So loader is what a kind of mechanism which performs all the necessary systems and applications programs into the main memory. Device drivers, it is basically the interface between the user and the system. It manages the connections between input and output devices. It works as an interface between the request and responses. Request which user made and device driver response that the system produces to fulfill these requests. Interrupt processing. The last part of resident monitor is interrupt processing. So, as name suggests, it processes all occurred interrupt to the system. As I earlier told you that resident monitor divides the whole memory into two parts, and that division is based on the boundary. Sometimes it is also referred as boundary address or fence address. Now we'll look into the matter that how that fence address is going to communicate with the user program area. Now consider a scenario when a user demanded uh, memory area of 1800. Some memory reference is 1800, and our boundary or fence is situated at 1500. So the resident monitor will check whether the demanding address is greater than or equals to the fence address or not. If the demanding address is greater than the fence address, then for that very program or that very process, main memory is allocated. And if it is not, then it goes into the trap. This is what resident monitor works. Thank you.